Okay. Now, to be more elaborate on the conceiving and perceiving aspect of engineering design. So when I say this is what do you call it as the raw cognition, which is nothing but your conceiving. It's your thinking inside. Okay, it's a brain work where you have the raw cognition. Okay, cognitive ability of the brain. It maps on to the fertile imagination, where you'll be having a cognitive curiosity. Okay, why? Curiosity is something you are seeking an answer for for a question which keeps, which makes you to be curious. Okay, curious to know. It's something very important, cognitive ability. And of course, the second is going to be some instinct. It is basically based on the expertise you have in one particular field, and you feel that incorporating a particular feature into the technology or doing some modifications will enhance the performance. So you will have a basic instinct, okay, that keeps lingering in your mind. And the third one is the pattern. So pattern is something you observe in the mind. You have a historic data. You analyze, and there'll be a lot of thoughts rushing into your head, and probably you will have a confusion state of mind. Then you come to, based on your experience or whatever things you have thought about, then you will come to a conclusion that the things will follow a certain pattern. Okay, so that pattern, and the other one is the observation. So normally when you see things, probably you will come to some conclusions internally that this will have this type of pattern, or the things that are being followed spontaneously, and things that needs to be stimulated, the things that needs to be taken care of, those things comes from the observation. Second was exploratory. You seek answers for some questions for which you need facts and figures. So you need to explore. So the exploratory mindset. And perception is every human being, they have their own viewpoint. Is the perception varies, especially even still today, a lot of thoughts are being, school of thoughts on the customer's perception. So understanding the customers is very difficult because you're going to deal with multi-generational customers. Gen Alpha, Gen C, Alpha, and Beta generation. So that is one. And the other human factors, normally it is also associated with the societal influence. So society will have an influence, and that will affect the that will have different versions of human factors. Okay, so based on all these things, finally what your brain generates is new ideas or concepts, so which are not proven or not tested. So untested ideas and untested concepts. So this is basically a raw ideation of the design, raw ideation. Okay, so these are all the raw ideation. You don't have it's not tested, and you need to go for testing, evaluating, then proving that your concept works good. So ultimately what happens is, next you go for a structured intention, which is nothing but your perceive. Okay, perceive. So what is structured intention? So structured intention is, see, a raw idea is something like a directional. It's not directed to a particular problem solving. So what I do is, I convert all my raw imaginations or ideas or concepts into specifications. So this is what very important. And what a specification will have, you can see it will list all the requirements. The requirements can come from a customer, what do you call it as a need analysis, or a scorecard, balanced scorecard can give certain requirements comparing with your competitors or the markets. And added to that, you have any design will be having very important two categorization, which is constraints and limitations. So what is a limitation? What is a constraint? So constraint is which you can play You can control, you can reduce. But limitations, you have to live with it. That is, you have to coexist with the limitations. Say, to a man, a woman is a limitation, and to a woman, a man is a limitation. So what happens is they coexist. Okay. So there is a system, there are limitations, which you cannot reduce, which you cannot ignore. You have to go along with it. So those things you have to categorize the problem under these constraints and limitations. Sometimes what happens is design engineers, they fail in categorizing limitations and constraint. They take some limitations and they think that is a constraint, and they waste their time working on solving those problems which cannot be solved. So the basic idea is you have to first be an expert to categorize what are all the limitations and constraints for a particular system or a design. Then you have an execution plan, then you have a strategy, then you have to go for some sort of analytical calculations, because you need to prove, you need to test your idea, and for which normally we used to rely upon different the tools that are being used, and all these will be covered by the new product development team, NPD. If you go to an industry, especially manufacturing industry, you will have a new product development team which takes care of all these things. This is the base work. Of course, they is not going to involve in design. Design engineers will be there, but he will form a cross-functional team. People from various functions, they will come together, and probably they will discuss on all these, because each and every responsibility that has to be assigned, because you have short time, that is lead time to introduce your product to the market. Now it has shortened. If you look at an automobile, four-wheeler car, for example, earlier it was like 2 years. They used to introduce one variant every year or maybe every 2 years. But now they have only 4 to 6 months. So every 6 months they have to introduce a new car into the market. Otherwise, they are dead. Okay. So when I look at the what you can call it as the concepts, specifications, both has to be tested, right? So the specifications, finally you have arrived, the embodiment of your design, the the elements of your design. Then you are going for a lot of study. One study is basically feasibility analysis. See, feasibility, when I say practically whether it is possible or not. Second one is economically whether it is possible or not. There are a lot of feasibility, say technical, financial feasibility is there, operational feasibility is there, export-import feasibility you have to analyze. There are a lot of supply chain management, that is also one feasibility study we look for. So those kind of feasibility studies has to be conducted before taking a decision whether to go with the design or not. So that is one feasibility. The second one is safety. So safety, once again, is very, very important. So do it right the first time, cost effectively and safety consciously. So when I say cost effectively and safety, so cost and safety both are very, very important, because cost you have to reduce it, because that's an expense. When you are reducing the expense, probably your profit margin increases. So where the cost will happen, if there is any rejections, if the process is not robust, the process is producing defective items. So those are all leads to increase in expense. So when you are increasing the expense, revenue remains the same, then what will happen to the profit? The profit will be, it will drastically reduce. The bottom line will be affected, right? So safety is also very important, as what I mentioned, because safety goes hand in hand with cost. Okay. So the third one is the optimization. So I need to, optimize my, system with respect to the parameters, or the optimization of the input variables, so that I get an optimized output variable. That will have an impact on the cost, say cost of rejection, cost of quality. There are a lot of cost mentioned, but that optimization plays an important role, because I'm going to deal with resources. Okay, human resource optimization is important. Material resource optimization is important. When I say the EB, connected power optimization is important. Supply chain optimization is important, transportation. Now, there are a lot of things that needs to be taken care of when I say optimization. Okay. The other one is the simulation. So simulation is whether I need to go for any proto testing, because some testing will be in the computers, what do you call it as a CAD CAM CAE, and there are certain products that needs to be tested physically, because it may, if anything goes wrong, it may lead to safety issues. So then I need to go for testing physically, or sometimes proto testing is very much essential for me to get approval from government bodies, regulatory bodies, or sometimes what you call it as the standardized standards. So I have to have a compliance with the standard, whether it is an environmental management standard or quality management standard. You have QMS and EMS. And of course, in automotive industries, they are using 6949 TS, technical specification. And ISO standards are there, environmental standards are there. So there's a lot of standards. And if I'm going to deal with export and import, then I need to follow a lot of protocols, standards defined by the country to which I'm exporting my product. So there is a lot of compliance that needs to be taken care of. And added to that, the cost modeling. So cost modeling is very, very important, because if you are not taking care of the cost during the initial stage of the design, then probably it's going to hit your profit, right? And it's a costly mistake if you're not. That is why in the NPD you have a lot of you do production part approval process, which you call it as a PPAP. Okay, and then you have an advanced product quality plan, which will be taken care of the R&D department. Then you have a manufacturing quality plan, which you call it as MPQP by the production engineering department. These are all the things which goes in, which is taken care of during the initial stages of the design, even before the realization of the product. Okay, so this is very important. So when I say cost modeling, I need to take care of everything, and I have to build product with inbuilt quality. I don't want to, go for any rework or, that's a waste of time, and as well as that increases the expenses. So the cost is very, very important. So cost optimization is also very important. It's not only modeling, it is also an optimization. Modeling basically people used to say that you have to fix the right selling price for the product. Take into account your profit margin, the miscellaneous, whatever it is, geopolitical scenarios and everything, your expertise, you have to put into it, and probably you have to come out with the different cost models. The last one is the standardization. As I have told you, you're going to deal with different countries as far as export is concerned, or you're going to import products, you're going to have a regional distribution, or you have to have a multinational distribution, or going to deal with elite customers. You become an elite customer, say to a Boeing or Airbus, then you have to follow the standards defined by individual organizations. Sometimes there are regulatory bodies are there. Say for example, if you are dealing with boiler equipments, then you have to get the Indian boiler codes, and you have to get approval from the government regulators, because that leads to safety issues. So wherever safety is very important, critical, the standards comes into play. You have to establish a compliance. Otherwise, probably you will not get a nod for proceeding with further production and launch in the market. So this is very important. Okay. Now, doing all these things by different functional expertise coming together and forming what you call it as a cross-functional team, their intention is to have check on every aspect of the design. See, design is an idea you convert into something, a physical prototype. But behind that physical prototype, there are a lot of decision making that happens in an industry, and each and every decision making ultimately will affect the value of the product. So that is why I put, whenever say realization, you are going to have what do you call it as a value addition. So what is the realization? It is the value potential, right? Whether it is realization will be with respect to product or service, but whatever it is, say service is having a value. Okay, customer retention, that is a value. Okay, products, that is customer satisfaction, that is the value which you create with your product. Okay, so the value is something what you can call it as brand. Okay, so this branding is very important. Okay, so the value is branding, nothing else. So if you want to be successful design engineer, then ultimately you have to enhance your realization potential whether it is for a product or a service, whatever it is. It means that ultimately it should end up with a good branding. Okay, so that engineering design is nothing but value engineering. So engineering design is basically a value engineering. So you're going to add value, and by adding value, you can, become a successful manufacturer or seller, whatever it is, in the market. You will have a competitive edge over your competitors. So that value plays an important role. So for that, you need to ascertain all these factors which will be taken care of in an industry. There will be different, subject matter experts will be there, functional experts will be there. They all come together and they work with the new product development team, under which there are a lot of standards being followed. PPAP is one standard, APQP is another standard, MPQP is another standard. And if you're dealing with the bought-out component, then you have a vendor quality rating. So there are a lot of standards that is available in industry. And especially if you look at the compliance, that takes care of all these things. Okay, there are different classes that are listed in the standards, where one class speaks about feasibility study, where one class speaks about safety, there is one class which speaks about resource utilization. Okay, so these are all the things that you need to, review during the design process. So today we have discussed about the basic understanding of an engineering design, and this is applicable to any code. Say if I am an AI engineer, then what I need to look for? My raw imagination, I'll be working on data, right? What will be my realization? I'll be finding out the pattern, right? So I need to go for understanding the pattern. Okay, data is available. I'll be employing AI algorithms or machine learning algorithms. Then finally, I'm going to come out with patterns, right? So that is what say sales pattern. Or if you want to analyze the resource utilization pattern, or if you want to analyze, the market dynamism of the market. Okay, so all you can make it in a dashboard, right? So whatever I've listed here, you can create a dashboard using AI. So that is how you'll integrate AI. There are n number of tools you can use: statistical process control, statistical quality control, TPS, Toyota Production Systems, Japanese quality management. There are a hell a lot of tools that are available for you to effectively use. But ultimately, the end, you should create value. Okay, you should create value, and that value leads to branding. That branding is your equity potential. Okay, in the market, if you're going to stand in the market, then you should have equity potential, which you call it as the branding. Okay, and that branding or creating that branding, maintaining that equity potential, that is very, very critical and crucial for any organization, whether it is a manufacturing industry or IT services industry or any industry. A lot of these kind of analysis are being carried out, and there are other tools like balanced scorecard, where you also include the competition into it, then analyze what are all the important features that your product need to have, so that you have a competitive edge over your competitor. So these are all the things that you need to assimilate, and while doing this design from the initial stage, each and every step that has to be. Okay, so today we're going to discuss about a very important and a fundamental understanding about engineering design. So irrespective of the code, we're going to understand what basically a design means and what are all the things that are taken care of during the design stage, and the basic understanding of design in a modern perspective. So in a modern art of design, probably takes into account some of the traditional practices, and added to that, a level of smartness is imbibed because you're going to make a lot of decisions during each and every stages of design. So let us look into some very important aspects of engineering design. The first thing is, when I say design, it is defined in such a way that engineering design is a continuous loop of conceiving and perceiving, that is conceiving and perceiving data or existing system, and of course if you want to come up with a new invention. So what actually this conceiving and perceiving means? So conceiving is something which you call it as a raw imagination. Okay, sometimes designs, you'll be thinking about some sort of a completely new, which is going to satisfy certain functionalities, or maybe a completely new feature that will be invented, a new technology will be invented. So the first thing that is going to be from the human brain, and of course what do you call it as a raw imagination, because imagination is different, because raw imagination is something very unique, untested. Okay, it is raw, it is not tested, it is untested. And now what happens is, there is one more which you call it as a perceiving. Perceiving is nothing but observation, or what you see actually, physically what you see, or sometimes it is also referred to as realization of the imagination. Sometimes it is also referred to as realization. Therefore, you can see that both a design engineer will have a raw imagination, and it has to be converted into a potential product or service or technology, whatever, or a new function. Okay, that realization potential is what you call it as a perceiving. Therefore, it is a combination of conceive and perceive. Okay, that's why we call it as an engineering design is a continuous loop. Okay, which will be, including both, that is inclusion of both the imagination, that is the human potential, human brain imagination, raw ideas, concepts, or whatever it is, then converting those raw ideas or concepts into real product, that is what you call it as a realization phase. Okay, so now before getting into that, the conceiving and perceiving, there should be some intention or a purpose for which you start thinking of creating a new product, or maybe enhancing service levels, or maybe improvising your, that is enhancing the performance of the product. So there is some intention or purpose behind that, right? So that is what you call it as the intervention. Okay, so what sort of interventions normally the design engineer has to look for, or where he gets the intention or purpose? Sometimes he generates his own, or sometimes he is being pushed. Okay, a market is a good example, a competition is a very good example. Okay, those are all the factors, or the competitors' technology, or your products which is available in the market, the customer's perception, customer's viewpoint of acceptance level of the customer's acceptance levels for particular product. There are so many things that happens, even geopolitical situations or circumstances that leads to these kind of changes that normally happens in the existing system. If it is a new system, it has to be tested, it has to follow certain procedures, compliance before getting launched in the market. So when I say intervention, there are two basic types of interventions. One is disruption, the other one is evolution. So what is evolution? Evolution is, already we have some technology and the technology is evolving. Okay, add-on features. If you look at the smartphones, every day you can see a lot of smartphones where the features are being added like anything. There are a number of apps being, it is available in the market. So that is what you call it as the existing technology. Oh, that is getting improvised, or you can say it is improved and it is being pushed for improvement whatsoever. But the evolution deals with, you can say it's a current state of matter. Okay, on which you're going to apply your changes and you're going to modify it for the betterment of, say, functional improvement, sorry, or service improvements, improving the customer's acceptance rate. There are so many parameters that normally we'll be discussing later. So this evolution is something, the current state of mind. And then what is disruption? Disruption is there is something which is already in the market, a typical operating system, but still, what do you call it, as a normal, environment. And suddenly something disrupts the environment, maybe for an improvement, because that can be the intention, or maybe for the ease of, doing things. A lot of things, and that's what I've been explaining you about the intention or purpose or the objective. It depends. Okay. So disruption is, it disrupts the market, it disrupts the technology, and it doesn't mean that the disruption is going to fetch you huge revenue. Of course it can, but not huge profits. Say, for example, what is disruption? If you look at, so far we have been discussing, we all know that earlier we have been using cable TV connections, but now we have Netflix. Okay, Netflix is a disruption in the, what you can call it as the sector, that is entertainment sector. So earlier we used to have cable TVs. Okay, now that infrastructure is totally collapsed because we have Netflix, we have Prime Video, everything from the satellites. So the other one is, say, smartphone. Smartphone, we know a lot of, integrated technologies we have into the smartphone. But a very good example will be the touch screen. So what is touch screen? Say, a touch screen enables the user to access different technologies which was earlier individually dealt, but now you have all those technologies integrated. So one such thing is the touch screen. See, using the touch screen, I'm not saying touch screen is going to do all these functions, but the touch screen enables the user to go for computing. The phone can be used, the smartphone can be used for computing. The smartphones can be used for navigation. You can browse, that is, you can use internet. You can take photos, that is photography, and there are a hell a lot of apps that is available in the smartphone. And what is that interface between the user and the smartphone? It is a touch screen. So touch screen is a disruption. Okay, it is not a new technology. It is a disruption. Okay, that has introduced changes in the way of working or dealing with the machines, equipments, there are a lot of gadgets, or whatever you say. But what I want, to thrust upon is the normal procedure is disrupted. Because smartphone, earlier versions doesn't have a touch screen. The basic version doesn't have a touch screen. Then smartphones were introduced, and touch screen, you can, it's just a very easy way of accessing to different technologies. Earlier it was an individual, function. So now it is integrated, and touch screen has become the disruption in the smartphone. Okay, so this disruption and the evolution, that is the technology or the current state of technologies that are available, it both combines and innovates things. So what is innovation? Innovation is to existing system, you are removing the redundancy, the complexities, and making it very simple for the customer, right? So that is what innovation means, because creativity is totally different, innovation is totally different. So this engineering design concept of conceive and perceive, okay? Then you think about intervention using disruption, or it is what you can call it as an evolution, and finally you're going to innovate the product. Okay, that innovation is something which you call it as a touch screen in a smartphone. Okay, touch screen in a smartphone. So it becomes the enabler. It's a technology enabler, right? So basically now if you look at any product, you can very well appreciate that a product has now become an integrated solution provider. Okay, earlier it was, as I've been telling you, that it was individual. There are a lot of different equipments for different functions, and now you have a single piece with multifunctional features. So this is what you're going to understand, the very basic definition of engineering design. It's a continuous loop of conceiving and perceiving. Okay, and under conceive, what are all the things? It is the it is the raw imagination. What do you call it? It's a raw cognitive ability of the brain. And if you look at the perceiving, is the realization, that is the actual potential. I can say the perceiving is nothing but the value which you add to the product or service. Okay, so that is a different school of thought, but probably we'll be discussing all those things. And now if you look at